Hi everyone, thank you for coming to my talk. This talk is about virtual and augmented reality on the web. And it's going to talk about WebXR, which is a future standard that's coming to the web, and about how we can start experimenting with it now. And my clicker stopped working. And the whole keyboard has stopped working. I can click through. Sorry. So just to introduce myself first, I'm a developer advocate, a web developer advocate at Samsung Internet, which is a little-known browser by Samsung. It's the web browser that's the default on Samsung phones, and it's also available on other Android devices. So if some of you have Android phones, you might have used it without ever really thinking about it. But if you have any questions about the browser or any issues that you come across with your websites, then I'm probably the person to ask about it. So please do, and I'll try and help out. But this talk is about how physical and digital worlds are merging. And I think it's an exciting time for this because we're starting to see some really interesting mixed reality headsets coming out. We've had the HoloLens for a little while, which we might get another version of soon. We've got, we had just last week Leap Motion's North Star headset announced. And we have Magic Leap 1 coming out this year, and starting to get shipped to early partners now. We also, as well as just these headsets, we have increasing capabilities just on our mobile phones with ARCore on Android and ARKit on iOS, and I'll share a bit more about those later. But first, what do I mean by XR? What do we mean by XR? At first, when I came across it, I was sure I'd heard that it stood for cross reality. I thought that made sense because it's about crossing this whole spectrum of realities alternate from our real reality. So everything from augmented reality to virtual reality. My colleague Diego, though, thought it stood for extensible reality, as in extending our reality with augmentation or with virtual worlds. But we checked on it, and it turns out it stands for whatever you want reality. And apparently the idea actually came originally from putting a V for virtual on top of an A for augmented, and that creates you an X. But basically, we mean anything from augmented reality all the way through to virtual reality, and the focus for this talk is going to be on something in the middle. We can have headset-based mixed reality, as I mentioned, and we can do that with virtual reality headsets. If they have cameras or they're used with a phone that you put inside and the phone has a camera, then you can use a feed from the camera and you can use that to display things inside the virtual reality headset. Or you have dedicated mixed reality headsets like some of those that I mentioned earlier. So this is an example with our own Samsung Internet for Gear VR browser, which is a virtual reality browser. And this is a demo that one of our colleagues made, which is just a simple demo to show that even though it's a VR headset, we can start doing some simple AR. In this case, it looks for a marker, and when it detects it, it displays a logo on top. But of course, this headset is not designed for mixed reality, and the camera feed is going to have some latency. So maybe that won't be acceptable beyond some experiments. Whereas headsets like HoloLens are designed for mixed reality, and we can have some pretty cool things like HoloLens, where we have interaction between the virtual objects and our real-world objects around us, and have some lemmings cross around in our living room. We've also been teased with lots of Magic Leap demos, and this is one of the collaborations that they shared recently in partnership with Star Wars. But today, I'd like to focus mostly on this mobile-based mixed reality, things that we can do just with our smartphones, especially following last year's arrival of ARCore and ARKit. Of course, this won't be as immersive as the mixed reality uses these headsets, but it does mean that we can start to get these experiences just from our mobile device, which can be quite accessible. So ARCore and ARKit, if you didn't go to the previous talk that mentioned these features earlier in the conference as well, the kind of things that they give us are the ability to do position and motion tracking. So they combine the camera feed with motion sensor data from the phone in order to try to understand where things are in a 3D environment around us. And they have some basic understanding of the environment around us. So initially, essentially detecting surfaces. They can detect flat things. Both of them also provide light estimation. So here's an example, which is on, I think this one uses ARKit, and it might be on ARCore too. This one is from Sotheby's, which is an auction organization, and this is an app that they made for checking out how your living room or how a room in your house would look if you kit it out with a whole new range of furniture. And you can even do things like tapping on the chairs and changing the color of the fabric. There's also IKEA have got a similar application called IKEA Place. Or if any of you are golfers, perhaps you were watching the Masters last weekend, and you might need a helping hand with your putts. So you could have point your phone at the green and use it to detect the slopes of the green to tell you where you have to hit your putt. If your friends that you're golfing with don't mind you cheating, of course. Or you could perhaps take one of your favorite games from when you were a child and bring it out into the real world around you by making an augmented reality version, as a developer did with Street Fighter. But what about the web? Well, the web has a very wide reach, and one of the things that is good already is that we have wide support for WebVR virtual reality just powered by websites. So on platforms like the Gear VR, Oculus, and Oculus Rift and HTC Vive, we can already have virtual reality experiences just powered by the web browser using various supported browsers. We also can do the same on Daydream, on Google Cardboard and similar devices, and in Windows Mixed Reality using Edge. And now we're starting to get experimental augmented reality browsers as well. So there is one called WebAR on ARCore, which is one that we can have on Android, WebAR on ARKit on iOS, and Mozilla also have one called the WebXR viewer that works on iOS. So these are web browsers, but they are built to integrate with ARCore and ARKit and provide those features to us as web developers that we can access through our website. And things are evolving quickly. We've just, in the last few months or weeks, had the announcement of the launch of SuperMedium, which is a dedicated VR browser that's being built by some of the people who used to be at Mozilla working on virtual reality there. And Mozilla also announced a dedicated VR browser called Firefox Reality. And Magic Leap have also said that there will be options for web developers to create content for the Magic Leap using web technologies too. So why the web though? Well, if you're like me, you might be a web developer, or you might know, as many people do, JavaScript and HTML and CSS. And these are the top 3 technologies from the most recent Stack Overflow developer survey. So there are many people with these skills. So if we can provide the ability to do augmented reality and virtual reality using these tools, then we are empowering a lot of people. And a great thing about the web is that it's accessible for people to dive in, because it's just a website. You can give someone a URL, they can tap on that link, and then straight away they have access to your application. And then from there, if they don't have a headset to hand. If they just have their mobile phone, they can just view it in that. We can also do what's called the magic window effect, where you're waving your phone around and you can see other parts of the 360-degree scene around you as you do so. But you can also, we can use what we call progressive enhancement and say, well, if that person does have a headset attached, then we can give them the full VR experience or the full AR experience. And we can also combine these web applications with other web technologies that are new and useful too. So if we're making a virtual reality, augmented reality web application, we can make use of progressive web app technologies too. We can make these things work offline. We can make it so that we can add an icon to our home screen and the user can launch it from there as if it's a native app. But just to rewind for a few minutes, I thought I'd share a little bit about the web's mixed reality evolution through some of my own experiments that I did over the years, because you might be thinking, well, how much of this is new and how much we've been able to do in the past? So it was back in 2011 that I made my first AR app, and it was quite simple, but the idea was that if you were abroad, like I am today here in Rome, you might like to find places to go, whether it's a restaurant or a hotel, and also then to have handy phrases linked to what type of place it is. So if it's a cafe, then you have a handy list of phrases there that you could use and play the audio so that you know how to pronounce it. This was developed with web technologies, HTML and JavaScript, but back then we didn't have access to the camera through web standards, certainly not on mobile anyway, so it required a native app wrapper, which was called Wikitude Architect. Then the following year, I was using Get User Media, which is part of the WebRTC standard. It was starting to become available on desktop browsers. And I tried out using JS AR Toolkit, which is a library that was based on originally something that was a Flash library, AR Toolkit. And that gave us the ability to have these kind of simple marker-based AR experiences again on the web. So in this case, I was holding up a marker and having a 3D dinosaur displayed on top using WebGL. Then a couple of years later, I started experimenting with the early WebVR spec. When I was at an education company called Pearson, we used it to try building a fire safety training demo so that you could train yourself up for how to deal with a fire and pick out the right fire extinguisher and point it at the fire, but in a safe environment so you don't actually have to put fires going in your office. And at the time, it was only available in experimental browser builds of Chrome and Firefox. But since then, we've gone on to have this WebVR standard available in browsers by default. And then last Christmas, I started experimenting with mobile-based MR. And in this case, this is when I started looking at WebAR and ARCore and trying stuff out with my Android phone. So as time has gone on, we've had WebVR becoming more and more of a burgeoning standard. And some people are doing it for pretty cool things already. So we've got, for example, people making storytelling experiences with Within. They have a WebVR version of their virtual reality app. People using it to be creative and make things in 3D. A-Painter is a great example that was made by Mozilla, which is essentially like a web version of Tilt Brush, if you're familiar with that. But one of the nice things about it being on the web is that once you've made your creation, you can share that just with someone by sending them a URL, and they can view it in their browser, even if they don't have a virtual reality headset. And also, it's neat to see people starting to use WebVR for things like education and bringing people together in a virtual environment. Some of the popular graphics libraries that we have for web development also make it straightforward to add virtual reality support. So three.ar.js is one that I guess some of you will be familiar with, very popular library, and that makes it pretty easy to integrate WebVR. A-Frame is a library that, if you haven't come across, is well worth taking a look. It actually uses three.js under the hood, but it allows you to write applications in a declarative way. Essentially, you're writing HTML, and it's using web components under the scenes to translate that into a WebGL scene in a canvas for you. There's also Babylon.js from Microsoft, which is another very popular one, which I haven't used it yet myself, but again, it includes features to straightforwardly add virtual reality support to your web application. And another one I haven't used yet myself, but that came around just a few weeks ago. Mozilla released WebVR assets for Unity 3D. So if you're a Unity developer or you know Unity developers and they would like to put experiences out that work on the web, then this is well worth checking out. So I won't focus further on virtual reality in this talk, but if you would like to get started with WebVR, I recommend A-Frame, as I mentioned, as a good and relatively easy way to get started. And so following the docs that they have online could be a good way to start trying stuff out. But next we're moving to WebXR. So what was the WebVR community is becoming the Immersive Web community group. And what was going to become the WebVR 2 API is becoming the WebXR device API. Essentially, the standard is growing to be able to incorporate augmented reality, mixed reality as well. And there is the Immersive Web community group on GitHub where you can find things like the actual spec that is in development, samples, and also polyfills that you can use to start trying things out now and to protect yourself from some of the API changes as they go ahead. A few quick things to note about WebXR. It's not actually going to be backwards compatible with the WebVR API. So if you have written a WebVR application, you may have a little bit of work to do to make it XR. But most WebVR apps apparently should port easily. And the two will run it side by side, so you don't need to upgrade everything straight away. If you have a WebVR app, that's fine. Also, it's worth noting that although this whole push to WebXR is about supporting AR as well as VR and everything in between, it's not going to be in the initial release, so we hear, but it is being designed to incorporate that soon, and it will be coming soon. And the idea initially, the first focus for it is on this phone-based AR, like we're seeing with ARKit and ARCore. You can actually already start trying out the WebXR API in the browser in Chrome. If you go into the flags and you enable it specifically, there should be an origin trial soon where you can apply to have it whitelisted for your domain for testing purposes for a while before the spec is ready. And if all things go well, then hopefully it will be released sometime later this year. A little warning before I go further ahead. The XR JavaScript libraries are in flux. The spec is in development. Things will change. So if you do start playing with this stuff now, then you will need to maintain things as it changes. But we can start exploring this now. I won't show too much of the actual APIs themselves, especially because most of us will probably be using libraries to work with them. But just quickly, previously where we had WebVR, and we would call navigator.getVR displays to get the list of attached devices, such as if you were on a desktop browser and it detects that you have an Oculus Rift plugged in, for example. With WebXR, it's going to be similar, but the spec currently is suggesting that we'll have a request device method, and that will give us back the default XR display that is configured in the browser. Mozilla have a library called three.ar.js that is based on three.js that I mentioned before, but designed for cross-reality, mixed reality. And it supports multiple browsers already, which is the nice thing. So we can build something with three.ar.js and have it support AR browsers, those experimental ones that I mentioned, and also VR browsers. And also there's nothing to stop us having some kind of experience, at least, in any normal browser too. And this one uses the new XR spec via Mozilla's own WebXR Polyfill, which they created a little while ago, but they recommend actually, if you're using the Polyfill yourself, to use now the new Immersive Web community group one. They also have a library called A-Frame XR, which again is based on A-Frame, but it adapts it to be able to use it for mixed reality. And this has the same support as 3XR library. So here's a basic demo using A-Frame XR. And one thing I wanted to mention is that, so in this example where it's on mobile in the left, even though this is using augmented reality, by default the objects are not staying in position, so I'm moving my phone forwards and I still never get to them. But that's because of the way we've just placed them in the scene. What's nice is that it also works, this is the same website in a desktop browser as normal, so there obviously we don't have the camera background. We also have different shapes displaying, and the reason for that is because A-Frame XR gives you a way to say, this object I actually just want to appear in augmented reality mode, and this one I just want to appear in regular mode or in virtual reality mode. So you can start to adapt your scenes and experiences based on the mode of use. So here's an example that shows things that do stay in place using a hit test. So now on this occasion, when I'm tapping there on the screen, it's doing a check to see if I've tapped on a surface, and if so, then it places an object in that position, and then that object stays there as I move my phone around. It's worth noting, though, that these AR examples that use these AR features at the moment with A-Frame XR won't work on non-AR browsers. This particular demo that they have, if you view it on just a normal desktop browser, for example, gives you just a white page except for the text at the top. We, though, decided to use three.ar.js, which is one from Google. And it has a few more examples available, and it looks as though it's a little bit further along right now. So once again, this one is based on 3DS, but it is AR specific, and it's going to be using those AR browsers, so WebVR on ARCore and WebVR on ARKit. And unfortunately, those are the only browsers that are supported with it right now. But we did have a better experience using this, and we ran into a couple of fewer bugs than we did with A-Frame XR. One thing to note is that this one doesn't use the WebXR spec or Polyfill yet. It's actually using the WebVR spec right now to get device information. So I expect that will be getting updated soon, but we can still use it for AR now. So who wants to see our demo of a dancing panda? Yeah, oh, there's a few of you, that's good, yeah. I didn't, I'm afraid, find a good way to stream my phone to do it live. So here's a pre-recorded one, which I will make sure I have the volume turned up for. So we have the little circle there is what's called the reticle, and you can see that displaying when you point your phone at a surface, so you can have that displayed automatically to indicate that that's a place that you can interact with. And then when you tap, you have the dancing panda and the animation there. And the full 1 minute of that video is up on YouTube, as I'm sure you want to check it out. So why and how did we do this? Why first is easy, because why not? But no, we needed something to brighten up our desks a bit at work. How is a little bit trickier, because to have that model animating took us a few different tools and a few points along the way. So thanks to my colleague Diego from the Samsung Internet who helped with all of that. So he originally created the model in blocks, which is something from Google. It's a tool that is designed for virtual reality, and it lets you create 3D objects in virtual reality using the HTC Vive or the Oculus Rift. And by default, that exports to Poly, which is their model store associated with it. Unfortunately, though, with Poly, you can only then export from there as an OBJ model format. And we needed FBX format for the next step. So at this point, Diego used Blender, the free desktop modeling app, to import the OBJ and then export it as FBX. Then we used Mixamo, which is an online tool for automatically rigging your models and making them animate. And they have loads of different predefined animations, including the Macarena dance that we saw. But we did have a problem with the rigging. But that first model that we tried using it with looked a bit weird. It looked like this. So he was, first of all, the panda was facing upwards, and the limbs were a bit strange. So we went back to Blender to adjust the model. We extended the arms and the legs out to make them more suitable for Mixamo's automatic model detection. And also, this was useful to clean up the model a little bit, and Diego did a few things to make sure that it was as neat as possible. Then we could export it as FBX and put it back into Mixamo again. And we had it then looking like this, which was a bit better. This followed a tutorial by Don McCurdy, which was really useful. So if you would like to go through the same process, I recommend it. But then we had to go back to Blender again and import the FBX model that we had from that. And at that point, make sure that the animations all look correct in Blender. And then finally, we could export it out as a GLTF. And GLTF is this common web model format, which is relatively new. It's designed to be a standard 3D format for the web, like JPEG is for images, but for 3D models. One thing to note also is that we had to use a specific GLTF exporter, one by Codemotion, which we found worked better with the animations. Now we have that. If we are to use A-frame, we can use it with just a couple of lines of code. We can, in our entity object here that we're just defining in HTML, and then using the A-frame library to transform that, we just need to add a couple of lines, one for the GLTF model, which is a component that will load that GLTF model in for us, and one for the animation mixer where we define that animation name that we want to play. And that gives us our WebVR version. That is up at samsunginter.net/Pandarena, if you would like to check it out. The panda animation is still slightly weird, as you might have seen from the video, but hopefully not too bad considering that we're not 3D animators and it was done automatically from the model for us. So that's our VR version using A-frame, but we wanted to have an AR version as well. So we went back to our three.ar.js, and to use that we can start by importing three.ar.js and a few other dependencies, including 3.js, the base library itself, also the GLTF loader. Then we can use the method getARDisplay to give us that. This actually gives us the XR device information that we need. If we get that back and we get a display, we know we're in an appropriate AR browser on an appropriate AR device. So at this point, we can initialize everything. Otherwise, we can use the inbuilt 3.ar display unsupported message to say, unfortunately, for now, we can't support other browsers. And hopefully, in the future, we can. Then we use the GLTF loader from 3 to load in our model. And we get the panda model from that scene. Then we are essentially doing the same thing as we had for A-frame, but just manually. So we'll create an animation mixer. And in this case, we're just playing all the animations that it finds. There's only the Macarena animation on there anyway. And finally, we can add that panda to our 3.js scene. Now we do the AR bit. So firstly, we're going to say when someone touches on the screen, we want to do that hit test to see if they've actually tapped on something that's a surface. So we can call the hit test method to do that. And if we have detected a hit, then we can call the place object at hit method, which handily will do that for us, placing the panda in that spot and keeping it there in that position. The rest of the code, if you're interested, if you'd like to do something yourselves to fork it, is up at our GitHub organization. And the actual demo is here, although, of course, as I mentioned, unfortunately, you would have to use the WebAR and ARCore browser or WebAR and ARKit browser and have the ARKit or AR-supported phones to be able to use it. And also, I should know that I haven't tested it on ARKit. But if you do happen to have one of those, then please try it out. There is also a version of A-Frame which works on top of three.ar.js, which we're using, A-Frame AR. So there's a lot of these libraries out there, as you can tell. We didn't use this one, but our colleague Ada did to make this demo where we were placing spinny versions of our Samsung Internet logo around us on the floor. So those were kind of silly and fun demos, simple demos. But hopefully you can see the way the future's going. I think this was a really cool video that was shared a little while ago from Kichi from Leap Motion. And this was giving a brief glimpse into what then was announced as the North Star headset. And this is wearing the augmented reality headset and being able to augment your hand using the Leap Motion hand tracker and then use that as an interface. The future is going to be pretty crazy with this stuff. And so I think, as people have said, I agree that we're at the beginning of a new era of computing with this. And if we explore it now, even though these things are early on, especially in web development, then it helps us to ask the right questions, find the right answers, and start to chart the course to a future we all want to live in. So what will you create? That's it from me. This is the link to the slides online and my social media if you want to reach out. And thank you for listening.